Hey everyone, welcome back to my channel. Today I'm giving another literature review on EOR, but this is covering the applications and the methods of EORs in unconventional reservoirs. This is covering paper ARMA 1081, and I'm pretty excited to share with you the general overview of this paper. This is going to dip your toes into the world of EOR compared to the previous paper that I presented a few months ago, and that's written in the description below. As usual, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video below so I can incorporate your feedback into future videos. Please be sure to hit that notification bell when you do subscribe because I upload every Friday and every Sunday. Every Friday is a professional development topic, and every Sunday is a technical review, such as this video. Well, let's get to the content. Hey everyone, today I'm going to talk about the application of EOR methods in unconventional reservoirs, and it's a review and data analysis written by Mukhtar El-Turki and Abdelmohsen Imkam. This is ARMA 1081, as I mentioned in the beginning of the video. The first EOR method I'm going to talk about is a miscible gas injection. And the next few slides are going to be visuals. The top left shows the different types of miscible gas injection that's been employed. The majority is huff and puff. The bottom left shows the different gases reported in unconventional studies, and primarily it's been CO2, with a whopping 75%. The top right shows the different types of gases, their minimum miscibility pressure, sweep efficiency, and cost, and what types of oil reservoirs they're best in. You'll notice that CO2 is really good for black oil reservoirs with the lowest minimum miscibility pressure. And then you have nitrogen with the lowest cost, and that's used in relatively lighter oil. The paper mostly talks about how CO2 can dissolve easily in shales, decreases the oil viscosity, and swells oil more effectively compared to other gases. The minimum miscibility pressure of CO2 is lower compared to other gases, but there are two disadvantages of CO2, which is corrosion and lack of availability. That's why there's been lots of murmurs of the use of hydrocarbon gas as a reality for huff and puff. And then huff and puff compared to flooding yields higher recovery factors. The next method I'll talk about is the water injection techniques. Low salinity water injection for wettability alteration and interfacial tension reduction is primarily used. From simulation results in this literature review, it shows the 10-year primary, 20-year water flooding, and 20-year water huff and puff, and their respective recovery factors. The next I'll talk about is chemical techniques. Common techniques are surfactant, alkaline, and polymer. Surfactant is the most commonly used, and the aim of chemical methods is to change the wettability of the reservoir from oil wet to water wet, which increases the oil recovery. So where and how is EOR being studied? We'll talk about the locations as well as what kinds of studies are mostly been reported. Top left shows the location in the misspelled Permian Basin, but the Bakken is where the majority of the EOR, unconventional EOR studies have been employed. The bottom left shows how from experimentation and from a simulation standpoint, that's where you have most of your published EOR studies. EOR and unconventionals has relatively been some uncharted territory. From a worldwide standpoint of where EOR is being employed, you have the United States with 74% of the projects. The paper gives some detail on data collection and processing methods. The data set was created based on 129 reported studies regarding unconventional reservoirs. This includes field and projects, simulation studies, and experimental tests. The following properties have been analyzed in the section, which were porosity, permeability, viscosity, temperature, minimum miscibility pressure, reservoir depth, and API gravity. Here are the porosity and perm plots where porosity and the majority is around 6 to 9%, with a median of about 7% in your bottom left. For perm, this looks like it's relatively high compared to my experience, but you're looking at 0.01 to 1 millidarcy reservoir. At that point, you start questioning whether this is ultra low permeability or if this should be classified as unconventional. That is a question as you have for the paper. And then you look at the permeability as well for the median, which you're looking at about 0.45 millidarcy. Minimum miscibility pressure, you're looking at between 2,500 to 3,500 psi with a median of about 3,000. Oil viscosity, you're looking at 1 to 3 centipoise with a median of about, for 1 to 3 centipoise as your majority of your studies, with a median of about 3.5. Reservoir pressure and API gravity is covered here. Depending on where you are and what basin you're referring to, this can be either low pressured or pretty high pressured, but you're looking at 5,000 to 7,500 psi of reservoir pressure as being the majority of where cases have been investigated. And then the median looks like it's about 5,500. For oil API gravity, you're looking at relatively light crude for the majority of the studies that have been published, with a median of about 42 degrees. For reservoir depth and temperature, depending on where you are in a particular basin and which basin you're referring to, you can be very deep or very shallow. But you're looking at 8,500 to 9,500 for the TVDs that have been reported, with an average of about 9,000. And for reservoir temperature, you're looking at 150 to 200 degrees. Relatively cool basins that we're talking about here, with the average of almost 200. I put the summary plots together where the top plot goes through all the parameters that I went through in the box plots and histograms, and what's the range of the data as well as the standard deviation. The bottom shows the 3 types of methods that the paper covers, as well as showing what are the advantages of the miscible gas injection method for the most potential EOR and unconventionals. And the table on the very right just shows what common rock and fluid properties are there in unconventional reservoirs with respect to the EOR studies that have been published. So that's just way more than what was analyzed in the histograms. But notice that the GOR at the very bottom, it's relatively low GOR as probable candidates for gas EOR or for huff and puff EOR. Here's some common problems in unconventionals that's been covered. For instance, your injectivity. Your water injection and flooding may be resulting in fractures in reservoirs. And if you're in the gas injection mode, the flooding part may be unsuccessful due to ultra low permeability. From an imbibition rate standpoint, the lower the imbibition rate, the lower the recovery from the reservoir. And then the imbibition rate of surfactant cannot proceed more than a few meters in unconventional reservoirs. That's everything that I wanted to talk about today relating to the paper. For more details, please check out ARMA 1081. Once again, please be sure to like this video, subscribe so you can get more content in oil and gas and professional development topics, and please be sure to comment on the video so I can incorporate your feedback into future videos. Follow me on Instagram, connect with me on LinkedIn, with Facebook, or with Twitter. Yoga Shri Pradhan is the handle for all of those platforms. Thanks so much again for taking the time to watch and listen to this presentation, and I hope to see you in the next one.